Have you ever thought about this? Are your ears actually older than you are? Well, today we're going to put them to the test, and then we'll dive into the really cool science behind what you can and maybe can't hear.
Okay, let's just jump right into it. I'm about to play a few sounds for you. Each one's going to be a little higher in pitch than the last. All you got to do is listen, really listen, and see how far up the scale you can go. Ready? Let's do this.
Okay, here comes the first one. This is 8,000 hertz. Now, pretty much everyone with healthy hearing should be able to hear this one no problem. All right, let's take it up a notch. Next up is 12,000 hertz. Still with me? This is where it starts to get interesting. It's in this range that some age-related hearing loss might start to creep in. But yeah, most of us should still be able to catch this one. Okay, here we go, 15,000 hertz. We are definitely getting into some selective territory now. A lot of adults might find this one a bit tricky. So, how are you doing? Still with me? And now for the final challenge, a super high-pitched 17,000 hertz. Okay, this one's tough, so listen really close. If you can actually hear this, wow, your ears are in seriously great shape.
So what's the verdict? How'd you do? If you managed to hear every single one of those sounds all the way up to that crazy high 17,000 hertz tone, well, there's a pretty good chance you're under 20 years old. Isn't that wild? This slow, steady loss of the high-pitched sounds is just a totally natural part of getting older. It even has a fancy name, presbycusis. But the real question is, why? Why does this happen?
Well, it all comes down to what's happening deep inside your inner ear as you get older. And the thing is, it's a one-way street. There's no going back. You know, it's pretty incredible when you stop to think about it. If you get a cut on your skin, it heals. Your liver can actually regenerate itself. But the super delicate, complex parts of your inner ear, nope, they don't have that ability. Once the damage is done, it's permanent. So let me introduce you to the main characters in this whole story. Thousands of tiny little nerve cells called hair cells. Just imagine them as these tiny microscopic microphones packed inside your ear. Their entire job is to catch all the sound frequencies coming in and turn them into signals your brain can actually process as sound. But that still leaves the question, why is it always the high-pitched sounds that disappear first? It seems kind of random, but it's not. Not at all. There's a very specific physical reason why they're the first to fall. So here's how hearing basically works. It's actually a pretty cool, simple process. Sound waves, which are just waves of pressure in the air, travel into your ear. They make those little hair cells vibrate and bend, and that physical motion, it gets converted almost like magic into an electrical signal that shoots up to your brain, and boom, that's hearing. Okay, and this is the crucial part. Inside your inner ear, there's a snail-shaped thing called the cochlea. And inside of that, the hair cells are lined up just like the keys on a piano, you know, from high notes to low notes. But here's the thing. The hair cells responsible for the high frequencies, they're located right at the front door. They're the first thing to get hit by every single sound wave that comes in. So because they're literally on the front lines, these high-pitched cells take on way more stress than all the others. They take the full force of every single noise you ever hear. And over a lifetime, that leads to this irreversible process of just wear and tear. Think of it like a welcome mat at your front door. It gets stepped on every single day. Well, constant noise, and especially loud noise, makes these super delicate hair cells bend and then break, and eventually they're just destroyed. And the really important takeaway here is they do not grow back. Once they're gone for good. And there you have it. That brings us right back to where we started. The slow, unstoppable loss of those frontline hair cells, that's exactly why the high-pitched sounds are the first to go as we get older. Your hearing is literally a physical record of every sound you've ever been exposed to. So this leads to a pretty wild thought, right? Your ears have their own age, and it might be totally different from your actual age. It really makes you think about your hearing as, well, a limited resource. So I'll leave you with this question to chew on. If your ears have an age, what can you do, starting right now, today, to protect their youth?